Hi class, this is Miss Park. Happy weekend. So as some of you guys wanted me to do, I'm making a midterm study guide. And if you do well on this study guide and the first paper study guide we had, then you're going to be just fine on the test on Monday. Please look through this and maybe pause, try out some problems. Okay, so let's get started. I'm just going to do practice problems and you can fast forward, rewind, however you feel to use this because this is not graded. But, you know, this is good supplementary work for you. So the first part is write a slope-intercept form of this line, right? So I give you the slope, I give you the y-intercept. The slope is 3 and the y-intercept is 5. The y-intercept is when x is 0. Remember that? So to write it in slope-intercept form, which is y equals mx plus b, I just replace the slope and the x-intercept, or the y-intercept. So slope is 3, so I'm going to replace m with 3. And the y-intercept is negative 5, so I'm going to replace b with negative 5. And that's all there is to it. You could write it like this, or you could write it like this. Okay, it's the same thing. Another thing I'll ask you to do is scientific notation. Remember, this is how you write a big number in short form or a very small number in short form. So for example, if I were to ask you to write this in scientific notation, this is a really big number, right? So automatically the decimal's in the back because I don't see a decimal. I'm going to move it where the first number is between 0 and 9, and then I times it to the 10th power of something, right? That's how you write scientific notation. So I'm going to keep moving this decimal until it gets between 0 and 9. And right now it's 146. So I got to keep moving. It's 14. I got to move one more time. And I moved it right there. Okay? So let's see how many times I've moved the decimal. I moved it once, twice, 3, 4, 5, 6, 7 times. So I'm going to write it as 1.46. I have to write all the digits except 0. Times 10 to the, is it going to be positive exponent or negative exponent? Well, it started off as a big number. So how I remember it is, if it's a big number, it's going to be a big exponent. There we go. Now let's go the opposite way. Say I tell you to write this in standard form, 7.56 times 10 to the negative 3. Right? So the negative exponent tells me it's going to be a small number. So I'm going to move to the left to make it smaller. I'm going to move it 3 times to the left. So I'm going to take this and move it once, 2, 3. I'm going to add the zeros. So in standard form, my new number is 0, 0, 7, 5, 6. It's a point right there. And we're going to put a 0 in front of it just to show that there's a dot there. And this is my standard form of that scientific notation. Alright, the fourth part of the problem will be proportional or not, right? So proportional is when it goes to the origin. So give me a equation that's proportional and give me a proportional that's not proportional. So a proportional equation and a non-proportional equation, pause it, and let's see what you got. So what I came up with was y equals 4x plus 0. This number could be anything as long as your y-intercept is 0. Now, a non-proportional would be like y equals 4x plus 1. Any number other than 0 is not proportional because a proportional graph has to go through the origin. Alright, I will also ask you to write an equation from a word sentence. So let me give you an example of a word problem, and I want you to write it, translate it in an equation. Okay, let's look at this guy. It says 12 less than 3 times the number is 10 more than 4 times the number. So I'm going to start highlighting or underlining less than 3 times a number, 12. I'm going to underline 10 more than 4 times a number, okay? So 12 less than 3 times a number means 12 less than means 12 comes after. So I'm going to put 12 after. 3 times a number is 3 times the number and 12 less than. So remember, it is not this, okay? 12 has to come after. Is means equal, 10 more than 4 times the number. And that's all. I mean, later on I'll ask you to solve problems like this, but for this one, all you're doing is translating it. For some reason, a lot of you guys had problems ordering and comparing numbers. when I did the review yesterday. So I want you to pause this and try to order this from ascending order, meaning least to greatest, okay? So I want you to order this from least to greatest, and let's see what you get. So since I want to order this from least to greatest, I'm going to separate these from positive to negative. It's kind of what my first period Joshua was doing. So I put all my positives up here. And I'm going to put all my negatives down here, because I know I'm going to have to list my negatives first since it's going from least to greatest. So I'm going to split them up, and I'm going to compare the negatives. Which one is, let me just make this one a little smaller. Which one is greater, negative 1.625 or negative 1.66? Well, on the negative side, the bigger the number, the smaller it is, right? So this number is smaller, so negative 1.66 is the smallest number. Then, obviously the next one's smaller because that's the other negative number. And then I'm going to compare the positives. Now, which one is the least number? 0.33. Then I have 2.25. Then 3.1 is my greatest number. So that's how I would do it. I would split them up between negatives and positives if we have different signs and then start comparing. But first, I would always either convert everything to decimals or convert everything to fractions, whichever you're more comfortable with, and compare it from there. Okay, do the same thing. Compare this from least to greatest. Okay, the first thing I did was I converted it all to decimal, so I'm just going to start comparing. The smallest one is between this one and this one, right? Now, how I know that is I look at each place value. I can line them up to make myself feel better. Let's line them up. Okay? I'm going to line them up in decimals like this, and I see that all of them have 1 in the 10th place. Now I go to next place value, and all of them, well, these two have 1s in the hundreds place, so I'm going to compare those. And if there's nothing here, I'm going to put a 0. Which one's bigger, 110 or 111? 111's bigger, so this one's the smallest. So this one's the smallest. Then I have this one being the next smallest. Then I compare these two, put a 0 there. Which one's bigger, 120 or 125? 125 is bigger, so this one's the third, and this one is the greatest. And then I rewrite it the way it came out as. So the first one was actually 11%. The second one was 1/9. The third one was 0.12, and the last one was 1/8, and that's how I order it from least to greatest. So I told you before, slope will be on there a lot, okay? So you gotta know what slope is. I know you probably hate that word by now, but you need to know what that is. Or say, for example, I gave you this. Excuse me. I'm still getting over a cold. Okay. Let's see. Okay, see, I gave you this table, and I said, give me the slope and y-intercept. Well, let's do the slope first. Slope is always the change in the y over change in the x. So let's look at the change. I add 3, I add 3, I add 3. The change in the y, I subtract 2. This is supposed to be a positive 3. Subtract 2, subtract 2. So my slope is 3 over negative 2. That's my slope. My y-intercept, I have to go back and find. Actually, I won't ask you for the y-intercept for this one. I'll just ask you for the slope. So here's the slope. That's it. Okay? Change of y over change in x. Now, this one, I'll ask you to find the slope and y-intercept. So let's look at the change in y over change in x, kind of like we did in the other problem. This time, I'll find the slope first, and then I'll find the y-intercept. And then I'll put it in slope-intercept form. So the change in y is minus 2 minus 2. The change in x is plus 3 plus 3. So my slope is negative 2 over 3. And now my y-intercept is when x is 0. Okay? So I don't see that on my table, so I gotta go find it. So if I move back 3, I get 0. Okay? And then I want to find out when that is when x equals 0, what is y? So I subtract 2, so to go back, I have to add 2. So that number is 9. So my y-intercept is 9. Does that make sense? I know we went over it a couple times in class. So to write my y-intercept form, I just replace m and I replace b. So remember, it's mx plus b. So I'm going to replace m with negative 2/3. And I'm going to replace b with 9, and there's my slope-intercept form. Negative 2/3 x plus 9. I will also ask you to name the slope-intercept form from a graph. Right? So try this one, pause it, and then unpause it to see if you got it right. Now, from the graph, I'm going to start with the y-intercept. Remember, that's my pinpoint. My y-intercept is where it hits the y-axis, which is 3. And then from there, I see it's a positive slope, so I'm just going to say it's positive. And I see from 2 points, here's 1 point, and here's another point, to see what the rise and run is. So I'm rising 2, 1, 2, and I'm running once. So my slope is 2 over 1. So to rewrite it, I would write y equals 2x plus 3. If I give you 2 points and asked you to find the slope, well, I would change it so it's in a table. So then I would say negative 4, 5, and 6, 3 to write it in the table. And then from there, I would do the same thing as I did last time. The change in the y, which is negative 2. The change in the x, which is plus 10. So then I have negative 2 over 10, which reduces to negative 1 over 5. Alright, so Plan A charges $125 a month plus $150 initiation fee, or initial fee. Say this is a gym. Plan B charges $200 a month. When will they cost the same? So you want to set up an equation and then solve that equation. Okay? So, pause it or whatever, but let's move on. Alright, so I have $125 a month. That's my x variable, so x represents month. And plus $150 initiation fee, meaning the initial cost. And I want to equal to each other, or let's not do that yet. So then I have another plan that charges $200 a month. I want to know when they'll be the same, so that's when I want to equal to each other. Alright, so that's how you set up an equation. Now we want to solve, like we usually do. We want to subtract 25x to both sides, get those common terms together. That goes away, it becomes 0. 150 equals, that's 75x. Divide both sides by 75, and x equals 2. So my answer is 2 months when they'll be the same. Okay? Another thing I wanted to talk about was function. How do I know when something is a function? Remember, x has to be a gentleman. So one input has to go to exactly one output. Only one. So for example, this, tell me if this is a function or not. Bam, bam, bam. Is that a function? Yes, it is. Even though they all go to 3, they all like the same person. 1 goes to exactly one function, 2 goes to exactly one number, one output, and 3 goes to exactly one output. That is a function. Something that's not a function would be something like this. One goes to 5, and 1 goes to 7. 2 goes to 5, 3 goes to 7. Now the point is, 1 can't go to 2 numbers. He is double timing, he is not a gentleman. Get out of here! Alright, so that's not a function. You will also be shown a system of linear equations. Remember, a system of linear equations is when I have 2 lines, and I'll ask you to find the solution. The solution is where they cross. The solution is that point right there. So say, for example, let me give you a clear graph. I have 2 graphs, bam, and bam, and right there is 5, and up there is 2. And I say, what's that? What's the solution to that graph? You're going to tell me it's 5, 2. That's all there is. Easy peasy, right? We will also have what we just finished, the scale factor and reflection and translation. Okay, we'll also have those. So if I give you a triangle with like 2 and 4, or a rectangle, 2 and 4, another rectangle with like 8 and, 16, I ask you what's the scale factor from small triangle to big triangle. So I want the scale factor. This is the old, this is the new. You're going to tell me the scale factor, okay? So remember, It's no stinky feet. So we do the new first, which is 8. We look at one side. Over 2, scale factor is 4. I could also done 16 over 4, which is the scale factor of 4. So scale factor is 4. Now, if it was the other way around, say I said this was the new figure and this is the old figure, then things would look different, right? Then now, the new figure, the side length is no longer 8, it is 2 and 8. It's an old figure, and that reduces to 1/4. So you always have to pay attention from what is the new figure and what is the old figure. If I said that this point is reflected over the x-axis, reflected over x, okay? Who changes? If I take a look at it, here's 5, 2. 1, 2, 3, 4, 5, -2. And it reflects over the x-axis, it's going to fold up this way and become up here. The y value changes, not the x value, right? The y value becomes negative to positive. So, if I reflect over the x-axis, it's going to be 5, 2. Draw it out if you get confused, guys, okay? Now, if I reflect that over the y-axis, it's a different story. So if I said reflect that point over the y-axis, then who changes, right? So I go from here and I fold it across to here, and now my x-axis changed from being positive to negative, so it becomes -5, 2. The y value doesn't change, it still stays down there. It's the x that changes, so think opposite. I'm almost done, guys. So this goes back to way back when I had Venn diagrams to show you the number system, right? Okay, so let's talk about the number system. This whole universe is called what? The whole universe of numbers is called the real numbers. Remember I told you there's imaginary numbers, but we're not getting to that in 8th grade. And then it splits off. Here is irrational, like pi and things like that. And then here is rational. Whoops. Rational. Okay, you're going to have to be able to distinguish these. And underneath these, there's several things too. There's integers and there's natural numbers, but let's stop here for now, right? So we have to be able to know at least this, okay? It's real numbers, then we have irrational and rational. And underneath rationals, we have numbers, okay? All right. Okay, I have 3 more things I want to go over. First thing is, if I give you numbers like 5, 2, 3, and 8, let's see. Let's not do that one. It's not going to be perfect. Hold on. I don't want decimals, so 15. Let's do this. 5, 2, and 8. I'm going to ask you to find the mean, and then, of course, I'll ask you to find the mad, okay? So go ahead and try to find the mean and mad of those. It's going to be 5 numbers on the real test, but we'll keep it for 3 for now, and tell me what you get. Did you get 5 as your mean? Okay, so you're going to add everything up and divide it by 3 because there are 3 numbers, and you get 5. So the mad, how I remember it, because I will never remember it myself, is by remembering the word glad. Okay, so G stands for get the mean. So we got the mean, which is 5. L stands for let's subtract. So I'm going to subtract 5 to all the numbers. So all these numbers, right? So 5 minus 5, 5 minus 2, 5 minus 8. So 5 minus 5 is 0, 5 minus 2 is 3, and 5 minus 8 is -3. A stands for absolute value. Let's call it all positive, okay? Because absolute value, you guys have a hard time remembering what that is. So I'm going to change everything to positive. Positive, there we go. And then I'm going to do it again, meaning do the mean again. So I'm going to add them all up, which is 0 plus 3, which is 6, and divide it by 3 numbers, 2. So my mad is 2, okay? Here is the last kind of problem. I will ask you to solve this and tell me what x is. So there's variables on both sides. I draw that river. I get all my x's on one side and all my constants on the other side. So I'm going to subtract 5x to both sides. Pause this and try it to see if you understand. Negative, this becomes x, 1x, minus 2. I just bring it down. This is 0, and I bring down the 4. Now I'm going to add 2 to both sides. I get x equals 6, and that's my final answer. Alright, so if you have any problems or you're stuck or you want more kinds of this question, like say I'm bad with scientific notation, shoot me an email and say, Miss Plot, give me more questions on scientific notation. Or I don't understand something that I said in the video, shoot me an email or remind, Miss Plot, can you clarify what you said on this second of this video? Blah, blah, blah. I'm here for you today, okay? And always. But, you know, I will be checking my phone every second. So please email me or text me. I hope you have a great weekend. I appreciate all your hard work. And we're almost at winter break. So hang in there, guys. Okay? Have a good day. Bye!